Hey folks, this is Chris Kornman, Lab and Education Manager at the Crown, and welcome to the physical analysis of green coffee. The physical analysis of green coffee can be broken down into four basic categories: size, density, water content, and defect count. Each of these metrics can have a bearing on any coffee's sensory quality and trade value. As such, it's worth the time of any roaster, coffee buyer, importer, exporter, processor, and farmer to have at least a cursory understanding of these important measurements, how they can be obtained, what their causes and effects might be, and to what degree they might be improved upon. Over the next few pages, we'll seek to cover both introductions to broad concepts and to dive deeply into misunderstood corners and clarify complex concepts in order to demystify the physical analysis of green coffee. This is Chapter 1, and we'll be dealing with screen size today. In subsequent chapters, we'll cover density, water activity, moisture content, and physical defect count. Screen size sorting at origin is usually the very last step in a long process. So we'll spend some time today taking a look at a number of different topics related to screen size. First, we'll examine the sorting machine at origin at dry mills. We'll also take a look at the tools that are used to measure screen size in labs. We'll look at global sizing conventions and some common trends across the world. We'll then get into some more qualitative and roasting implications, whether or not coffee sizing actually matters for anything, both financially and qualitatively. We'll look at the exceptions and outliers from those global trends, and then we'll look at specific examples of both roasting and cup quality. So as I mentioned earlier, screen sorting is usually the very last step that happens at the dry mill before the coffee is loaded into bags. The machines that do the work are large multi-tiered tables that sit atop each other at a slight downward slope. Each tier corresponds to different circumference, and the surface of each level is perforated accordingly with circular holes that allow smaller sizes to drop through and the larger sizes to pass over. The machine vibrates as coffee enters from above, separating the coffee simply using gravity and agitation. Workers will hold bags at the bottom of the machine to catch the outflow of coffee. Multiple passes through the device can increase the precision of sizing, and many of the machines can be adjusted manually. In the example in the image to the right, you'll see that the bags are positioned at the bottom of the screen here, and that at the top is where the coffee would be loaded through on the screens. In this particular example, we have bags grouped in sizes of 2 here. So for example, this might be our 18 screen size and our 17 screen size that are being blended together into this bag for export. Dry mills aren't usually the most beautiful of locations. They're usually fairly dusty. The equipment tends to be more functional than aesthetic. They tend to be pretty noisy places. There's a lot of coffee beans and a lot of metal. This particular example here is something that's fairly unique. It's an old vintage machine. I believe it's restored from a German producer. It's located in Brazil on Fazenda Camocim, which is located in Espírito Santo, and it's a beautiful example of something that's typically not typically this gorgeously produced, but you can see the function is essentially the same. The valves releasing the coffee and the different size tiers are all essentially the same mechanically. It's also fairly rare for these machines to be located on site at a farm. Brazilian coffee might be the exception in that regard, where you have a lot of relatively large estates. For most of the rest of the world, the dry mill, in its entirety, not just the screen size, but many of the other functions of the dry mill are located off-site at a third-party location. And typically, the coffee moves there once the exporter either owns it or has a buyer for it in the rest of the world. In labs, as well as in dry mill production facilities, screen size traditionally has been measured by passing coffee through these circular holes. The holes are typically measured in increments of 1/64th of an inch in diameter, so a coffee measuring screen size 16 means that that coffee is 16/64ths of an inch, or 1/4 of an inch across. The sizing is generally accepted worldwide. It's pretty well standardized, but there are a few select countries that have elected to either brand their coffee based on size or to rename these sizes to suit a particular interest. The equipment that's used in labs is also fairly standardized, and these screen size sets made up of trays that can run from, usually it's about the size 12 through 20 with a blank tray at the bottom to catch any of the smallest, usually chipped and broken pieces that fall through. They stack on top of each other, and they can be fairly expensive. Um, uh, the Crown supplier for this device, Coffee Lab Equipment, I believe they're selling them for about $75 per tray, or roughly a little over $1,000 for the entire set that comes with a case to slide them into. And this has kind of traditionally been the standard that comes in most professional quality labs. The folks that make Tonino and Artisan, the roast logging software, have recently released a device called Colino Coffee, and it's a 3D printed using sustainable materials, and the cost before shipping is a little under $200, which is pretty impressive. It makes that barrier to entry a lot lower. The size of the screen is significantly smaller, which can affect the accuracy, but you can always do multiple passes. Standard practice in most labs is to use 300 grams of coffee to do your grading. The top screen in most sets is usually the 20. I do not often use the size 12 screen or the 13. Mostly I just note that anything that passes through that bottom screen, the 14, it would be sized 13 and under, and I find that that's usually sufficiently accurate for my purposes. Use that blank tray at the bottom, the one that's just a catch-all, to get anything that's chipped or broken. I usually agitate for about 30 seconds, those trays stacked on top of each other and just shaking back and forth, and then I always put down a mat or a towel or something underneath to protect the table surface. And then the last thing that I'll do is one by one, I'll take the coffee from the top tier first and dump it into like a large bucket or some sort of bin, large enough to catch all that coffee without spilling. Tear your scale out, and once you have each of your individual tiers weighed out, you can add up your sum total. It should be close to that original 300 grams if you've done your measurements correctly. And then you can divide each tier by the total weight to get the percentage. That's what I find usually the most easy to understand way to display the information. So many different places in the world have elected to brand or to designate their screen size selections into these different naming conventions. And my colleague Evan Gilman, the creative director at the Crown, has drawn up this nice chart to help kind of break that down into more specific and visually understandable information. So at the bottom left, you'll see the key, which correlates color to the associated value of these particular sizes. And then above that key, you'll see the names of the places where these conventions are typically used. So starting at the top of the chart, in Brazil, if you're looking for the largest and highest quality beans, typically what you're looking for is that strictly soft fine cup, the 17s and 18s. A lot of times you'll see this NY23, or in the case of lower grades, a 3-4 perhaps. And that refers to the New York Commodities physical defect grading. It's a different system than the SCAs. It focuses more on protecting equipment. So the foreign matter it's a much more intensive grading system for that, but it's less concerned with things like broken beans. These two terms, strictly soft and fine cup, mean different things. Strictly soft in Brazilian nomenclature refers to the absence of hard cups. That would be defects like phenol or Rio, sensory defects that we would find in the cup. So strictly soft is a absence of that. And then fine cup would be cup score. A fine cup is the highest quality tier, and you can see that the next tier down might include words like good cup. You can also have other designations besides strictly soft, and it will go all the way to fully hard. That would be fully phenolic lots. In former British colonies, primarily places like India, Kenya, Tanzania, Zambia, Papua New Guinea also uses a modified version of this system. There are a few additional quirks there. They often will include an X in their letter designations to indicate that there's been a blend of multiple screen sizes together. And they recently whittled down their different screen size tiers from something like 15 to about 5 or 6. But in all the other countries mentioned here, these sizes are pretty standard. You see again the highest quality, or I should say the most expensive quality tier tends to be that AA category, the 18s and 19s, and the tolerance for coffees that fall outside of that particular range is very small. It's usually less than 5%. Below that, you'd see ABs. ABs in a lot of cases are graded for defects in exactly the same way as the AAs, and in some cases they come from the exact same lot. It's just that they've been separated into screen sizes. So I always like to look at the AAs from, or I should say the ABs from places like Kenya, as it's kind of an opportunity to maybe discover some excellent quality that's potentially undervalued just because it's a slightly smaller screen size. The less valuable coffees in this system would include Cs, that's the smaller beans. Defect counts tend to be higher in those. Es, which would be your extra large beans, the elephant size, not to be confused with the physical defect elephant ear. Those are two different things. And those largest beans tends to be pretty low in density. And then at the very bottom, we've got T, which includes broken beans and often foreign matter. It's called triage, and it's generally pretty trashy. In Central America, we have a much wider tolerance that's been accepted there. In most places, you would see this referred to as European prep. That's EP, and you might see that written at the end of your on your bags. American prep in this system includes that 15 to 18 size, but it also includes the smaller beans, the 13s and 14s. So European prep would be the strictest grading in Central America. You also see some terminology like strictly hard bean and strictly high grown. These mean two slightly different things. Strictly hard bean tends to refer to density, and strictly high grown refers to the elevation, but also is an indicator of density. And the idea here is that it's the very highest quality. You can also get these designations without the strictly. So you might, for example, see just HG as a high grown, and it refers to a less specific standard in that regard. Don't confuse strictly hard bean with the strictly soft cup in Brazil. Again, the strictly soft is about cup quality, and strictly hard bean is about physical quality. Lastly, we see that in Colombia, famously, has used the Supremo and Excelso designation to tier out their sizes of beans, and you can see they adhere pretty closely to other conventions in that regard, the 17s and 18s for the Supremos and the 15s and 16s for Excelsos. They slightly loosened their tolerance a couple of years ago, so you can usually get, it's about 90%, I think, that falls into those categories, and you're allowed to have a little bit of trickle over from the slightly larger and smaller sizes, but they're usually pretty strictly graded for that. The other tier that you see here is the UGQs, the usual good qualities, and that would be usual good compared to, say, a commodity grade. You're not going to find a whole lot of specialty coffee in that UGQ category. It's usually 80 points or below on the SCA scale. Across the globe, the size of coffee seeds directly relates to the sale price in a lot of cases. There are a number of markets to whom size can be an important factor. You may notice as a prime example that Kenyan-sized AA coffee typically trades at a higher value than ABs. In many cases, this seems to be tied up in a historical view of larger beans possessing higher quality. In some instances, this isn't necessarily wrong. Big beans can equate to larger, riper fruits. However, as far as using size as a proxy for high sensory quality, the viewpoint's perhaps a little dated. Yet it continues to be perpetuated by organizations like the International Trade Center and the International Coffee Organization, the latter claiming in their literature that the theory behind classification based on bean size is that coffees of the highest altitudes are more dense and larger in size than those produced at lower altitudes. Similarly, coffees develop more slowly at higher altitudes and often have the best flavor profiles. Now, there's definitely grains of truth in that statement, and it, I think, generally is true that higher density coffees tend to be more delicious and that they tend to be produced at higher altitudes. But we see plenty of examples of coffees grown at low elevations that may have large screen size, and plenty of examples of large screen size beans that may have lower sensory quality than their smaller bean counterparts. We'll look at a few examples of outliers in that regard in just a minute. But as a result of these views, with rare exception, the smallest screen size are excluded from high-grade specialty export and tend to trade at lower values. The large size mentality has also resulted in the development of cultivars, which may produce larger bean sizes in general. And you can think of a couple examples of these, I'm sure. One might be Pacamara, which regularly sizes 50% above screen size 19. The other one I can think of is the FNC in Colombia, the Coffee Growers Federation, which are intentionally developing cultivars that produce larger screen sizes, and the idea is that the farmer can capture higher profit margins if their trees are producing larger sizes that fall into that Supremo category, as opposed to settling for smaller sizes of the Excelso beans, which trade at lower values. So we have here a couple of examples of outliers to what might be considered those standard sizing conventions. The correlation of larger beans to higher elevations and higher density seems to me among the less well-founded of claims. Some research, including a published study in Nicaragua, may corroborate that assertion. However, ample evidence exists that many growing regions such as Nariño in southern Colombia, Rwanda's Nyamagabe district, Ethiopia's Gedeb and Sidama zones, and coffees from high elevation regions in Yemen, each of which are especially high elevations, produce smaller than average beans, yet are also well known for above average quality. Ethiopia in particular, I think, provides an interesting case study. Generally recognized as some of the highest quality specialty coffees on earth, Ethiopian coffees are almost universally small in size. Sizing conventions there tend to include screens which other countries would typically sort out. In a lot of cases, over half of the beans measure at size 15 and under. Nearly a quarter of the seeds pass through the next smallest screen. Under literally all of the standard grading systems in most other countries, nearly a quarter of this coffee would be practically thrown out with the trash. And yet, its inclusion doesn't prevent these coffees from phenomenal cup scores at the cupping table. So I think that's maybe one of the most relevant examples to how this sizing convention might be a disservice in some cases to coffees that might otherwise be exceptional. And I think that we see some resistance to this in the specialty quality micro lots these days. These, small, high-quality dry-pressed Yemens, for example, or our El Salvador Pacamaras that don't fall into these categories. Plenty of other examples. And the main one that I guess I see a lot of is the single estate Colombian coffees, which buck the tradition of grading into Supremos and Excelsos. Those sizing conventions, by and large, were created for bulked lots, for regional offerings, and the idea was that you could quickly identify, based on the size and sorting, what the quality tier would be. But for differentiated specialty from traceable producers, we see less need for that kind of size adherence. If you're able to cup the coffee and the quality of its taste can be vouched for, then the sizing convention seems to matter less. Pea berries present a really interesting anomaly when grading coffee, both by size and for physical flaws. Technically, the pea berry is a genetic defect. Instead of the typical two seeds that would grow inside of a normal coffee cherry, the zygote never splits and instead forms a single seed that's rounded on all sides. As opposed to the typical flat bean, which would be flat on one side and round on the other. There's a lot of folks that have claimed that this means there's more concentrated flavors. It's an allegation I regularly decline to perpetuate. Others may claim that it makes roasting more difficult, which is certainly true, especially if the pea berry comes mixed in with the standard flat beans or if they're poorly sorted. But in either case, no other genetic flaw in coffee really regularly garners such attention. These pea berries actually have their own screen shape for sorting on the tables. It's an oval shape rather than the perfectly round circle that we see. And this whole phenomenon has created some interesting market opportunities. So typically for any given coffee, about 5% of the harvested beans are going to be that pea berry shape. But what gets done with them is pretty different depending on where you might be in the world. For example, in Central America or South America, we rarely see these pea berries sorted out and sold at premiums or higher values, with a few rare exceptions of small microlots. But generally speaking, there's not a whole lot of bulk pea berry on the market. However, especially in places like Tanzania and Kenya, that pea berry idea has been sort of marketed to the roaster as something that's really special. Even though there's not necessarily any qualitative difference between it and the rest of the lot that it was separated from, those pea berries can trade at high values just because of their shape. Especially Tanzania is a prime example where they've done such a good job of marketing their pea berries that the American roaster, by and large, is demanding only pea berry from that country, despite the fact that 95% of the coffee that's produced there is the standard flat bean. So when it comes to the effect of screen size on roasting, it can alter thermodynamics in a few ways. Among the most important is the way that heat application and absorption may differ based on size and shape, something that scientists might refer to as the surface area to volume ratio of those beans. Heat affects the different sizes and different shapes differently depending on how much surface area is available for the heat to be absorbed by. For example, a batch of coffee possessing predominantly a single size of beans isn't necessarily a problem. The roaster can generally adapt to this scenario because the relative surface area and volumes of the seeds are fairly similar. They may have to make some changes based on sensory data, but it won't necessarily create unevenness in the roast. Challenges typically arise when a batch of beans has a widely disparate size and are roasted together. In these cases, the roast degree will differ somewhat significantly based on the disproportionate relationships of volume and surface area of the coffee. It's actually the same principle as if you're doing a lot of pre-roast blending. You may have coffees of different size and shapes, and you run into these problems where roasting them all at once together may create differences in the color and roast degree of that coffee once it's finished. So in the screen size example you see on the screen in front of you, we have an example of a coffee from Tolima in Colombia that was not graded according to the Supremo Excelso designations we're used to seeing. And there's a fairly wide distribution of coffee here. So the roaster is going to have to make some choices based on what the best practice is for a coffee like this, where the range of sizes is a little bit wider than average. However, sensory results are not completely predictable based on screen size alone. There's a lot of factors involved, obviously, and so it's really difficult to make general recommendations for roasting. No two coffees are going to behave the same way based solely on their screen size. I would say that one potential solution for a roaster If you're looking for nothing other than homogeneous color at the end of the roast, would be to slow your roast down for coffees that are of wider screen size distributions. That'll allow for more time for development of those coffees to kind of catch up to the ones that are developing a little bit faster. The last thing we should talk about here is the effect on roasting and some ways that you can experiment on this on your own, some ways to control your results and understand exactly what it is that you're dealing with. The graph on the right, what we see here is two roasts of the exact same coffee with the exact same roast approach. And on the one hand, the blue line is sort of the separated out single screen size, whereas the red line is the unsorted batch. And we can see in this particular example what's happened is that we've separated out a particular screen size, a single size of that bean, and it's actually absorbed the heat faster than the lot as a whole in general. And that's fairly common. You can kind of think of like those wide screen sizes as like producing some drag on a roast, slowing it down a little bit perhaps, reducing the rate of heat absorption. Whereas if you just have a single size in your roaster, it's going to be a little bit more efficient at heat absorption. The other thing that you can do here is that you can, if you have a programmable roaster like an Ikawa or a Loring, for example, you can actually create the exact same roast, time, temperature, airflow, all those different specs, and roast separated batches. Use a control roast of your unsorted batch and then separate into screen sizes if you have the ability. Loring is probably not super practical for that because you're going to have to filter out a lot of coffee. But the Ikawa is actually really efficient at this, so if you have that capability, roasting with a program, what you'll end up with is coffees at the end of these roasts that have been roasted to the same specs but probably have turned out at different color values and different flavors. So you should cup those and see how they turn out. If you're not able to do that with a programmed roast, it's not that hard to use a no-touch approach. For example, like in a sample roaster, if you can just set your heat to a level that will finish the roast in a reasonable amount of time, perhaps 7 or 8 minutes, and get that timing down exactly right, then what you can do is control as many variables as possible. Don't use any gas adjustments and roast to the exact same time on these separated lots, and you'll end up with some interesting quality results on those ends, some pretty observable differences in terms of the way that heat is applied and absorbed during the roast. And like I said in a previous slide, the last thing that you can do is actually just roast an unsorted batch and then sort by screen size after the roasting is complete, and you'll be able to taste some differences there too. Always cup and compare. Differences are going to be subtle in some cases, but they're almost always detectable. I do this a lot with groups. We taste together, and it's actually kind of remarkable how different these results can turn out. And people almost always have preferences. It's different. Every coffee is different every time. Sometimes it's the smaller sized lots that surprise us. The smallest beans in a particular lot that turn out like super zesty and delicious. Sometimes it's the larger ones. A lot of times it's kind of in the middle of the pack. There is where we find that sweet spot for our screen sizes. So hopefully this has been some useful information for you. Get out there, do a little bit of roasting on your own, do some experimentation, and see what kind of results you might get when you apply different heat approaches to different screen sizes. And hopefully this will also help you in your buying practices in the future, knowing exactly what it is that you're looking for when it comes to a particular lot of coffee. All right, so thanks for sticking around for this little webinar. Like I said, my name is Chris, and you can reach out to me at ckornman@royalcoffee.com if you have questions about this particular topic or any topic at all related to coffee education. And please stick around for future editions. We have 3 more chapters of physical analysis of coffee and lots of other interesting resources online for education. Enjoy your coffee.